So right now, we're going to be solving some kinematic equations. Now, there are 5 steps I recommend following when we try to solve kinematic equations. So the first step is to draw a picture to help visualize the problem. Then, write down the variables that you know and the variables that you are solving for. Once you've done that, choose an equation that includes the variable you are solving for, as well as the variables that you know. Once you have that, plug it into the equation, rearrange it, follow the order of operations, and solve for that missing variable. And then finally, check to make sure that the answer makes sense, and that if you do the math with the units, that the units end up matching what the variable should have those same units of. So, the example I'm going to be using is this one. A runner accelerates at 4.2 meters per square second for 10 seconds before winning the race. How far did they run? So, those 5 steps I'm going to be following. The first one is to draw a picture. It doesn't need to be a super detailed picture, just good enough to communicate what's happening. Right here, we have a runner. This right here is going to be the starting position, or the starting line. They start from not moving, and then they accelerate. So that means they're traveling faster and faster and faster, until finally they cross the finish line, and they win the race. So this just allows me to communicate what I'm seeing, and helps me to explain and justify the variables that I choose, which is the second step. So for this problem, a runner accelerates at 4.2 meters per square second. So I'm going to be able to say that this should be my acceleration. 4.2 meters per square second. They accelerate at that rate for 10 seconds. So my time is 10 seconds before winning the race. How far did they run? So really, I'm looking for that final position that they have here. Now, for these other variables, I don't know my starting position, my starting velocity, or my final velocity. This is where I might need to analyze the picture that I drew and make some assumptions. One of the assumptions I'm going to make is if we're trying to figure out how far they went from the beginning to the end. That's really the change in position. So if I just say that my starting position is a position of 0 meters, as long as I find the final position, that will be their total distance that they ended up running in a straight line. Another thing is, this is a runner. Before they start the race, they're probably not moving. So their starting velocity is going to be 0. What I do not know is what their final velocity is. And I don't need to solve for that because that's not what I'm trying to figure out in this problem. So this is my list of variables. I know the starting position, I'm looking for the final position. I know the starting velocity, I know the acceleration, and I know the time. So I have 3 equations that I'm really going to be looking at. And I will select the one that allows me to solve for the variable I'm looking for. So, the first equation, v equals at plus v naught. That's an equation that allows us to figure out the velocity if we know acceleration, time, and the starting velocity. We do know the starting velocity, acceleration, and time, so we could figure out the velocity after 10 seconds, but that's not what this problem is asking for, so I'm going to eliminate this equation. The next equation, it has us solve for the final velocity squared, and that's equal to 2 times the acceleration times the displacement plus the starting velocity squared. While we could rearrange that to figure out the displacement, what we're solving for, we would need to figure out the velocity at the end first. So I'm just going to eliminate that. That leaves me one equation. I'm looking for that x, that final position. I know the x naught, the starting position, the v naught, the starting velocity, the t, time, the acceleration, a, and the t squared, which would be the time squared. I have everything that I'm looking for. So I'm going to write down that equation. Position equals starting position plus starting velocity times time, plus 1/2 times my acceleration times time squared. I don't need to rearrange this to get what I'm looking for by itself because it's already isolated. So to figure out my position at 10 seconds, I plug in my starting position, 0 meters, plus my starting velocity, 0 meters per second, times the 10 seconds for my time, plus 1/2 times my acceleration of 4.2 meters per square second, times my time, 10 seconds, squared. Then I follow my order of operations. So the first thing that I'm going to need to do is to square that to 10 seconds. Everything else I'm just going to leave as it is until I get to that point. So 10 seconds squared, 10 squared is 100, and then the units would be seconds squared. After this, then I can do my multiplication and division operations. So at that point, that first term, 0 meters, stays by itself, plus 0 meters per second times 10 seconds would equal 0 meters. Those seconds would cancel out. Plus this last term, 1/2 times 4.2 times 100 is going to be 210. The second squared and the second squared end up canceling out, leaving me just with my units of meters. The last step I need to do is just to add these together. So that's going to be 0 plus 0 plus 210 is equal to 210 meters. Now this is the final step. I need to just check to make sure that my answer makes sense. I know that I should have a positive position because the way I set up my diagram is the person was moving in the positive direction. So they should have gone to some final positive position if they started off at a position of 0 meters. And then because I did all of my work with units, the fact that I ended up with units of meters means that I probably did the work correct, because I would expect position to have units of meters, and that's exactly what the work ended up showing.